Now it's time for us to look at each of the parts of the electromagnetic spectrum in turn, starting with those waves that have the longest wavelength. Here is an example of one of those. It is a radio receiver, otherwise known as like a radio that you listen to music on. Now, radio waves are encoded with information. That means they're used in telecommunications, communications that are sent through the airwaves. And if I turn this on, you can see that at the moment it's just picking up radio static. It can't make sense of anything that it is picking up. And I've turned that off. Now, radio communications were one of the very first parts of the electromagnetic spectrum to be fully utilised by people. Marconi, over 100 years ago, was the first to send radio communications across the Atlantic Ocean. And it meant that around the world people could communicate. And from that day, if you couldn't have a cable connecting you to the source of the information, sending it by radio was the best way. And this was utilised in things like ships. Ships like the Titanic, for example. When the Titanic started to sink and it used its famous SOS signal, there was no way the Titanic could be connected to the mainland by a cable, and so therefore it sent it through radio waves. We still use radio waves in situations where we are quite mobile, in cars, for example. Now, radio waves are completely harmless to human beings. They have no negative side effects whatsoever. But the same is not true for all parts of the electromagnetic spectrum, as we will soon find out. Now, this in my hand here is a microwave radar gun. And this microwave radar gun works by sending microwaves out of the front when I press the trigger. And of course, what that does is it flies away and it reflects off a surface like this wall, and then the waves come back to the source where they are detected. Now, what happens is the actual detector then looks at the Doppler effect on those microwaves to see if the returning signal has been shifted, as in the object that it's been hit has been travelling relative to the gun. And from this they can work out the speed of things. So let's give this a go. There we go, 5 miles per hour. So these radar guns are quite often used to determine the speed of, say, serves in tennis, or the speeds of cars through rural villages, and they are a really good use of microwaves. Notice the microwaves were completely invisible, you could neither see nor hear them, and yet they were useful. No way. No way. Yaha. 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 Get out. Anyway, folks, I want to just demonstrate this, the fact that this, in fact, is a demonstration of microwaves being used. Your mobile phone uses microwaves to broadcast a signal to the nearby antenna, and you might have seen those in the countryside, a silver-looking pylon, but with like some plates at the top. And your phone is in communication with that microwave transmitter. And between the two, it is sending encrypted, encoded microwaves that are received by the mast, sent to another mast, and then sent to the mobile phone that you're trying to contact. You see, microwaves have been used in communication for a very long period of time. Spacecraft in space use microwaves. You can't send a telephone wire all the way down to the Earth if you're in orbit. And so things like the Space Shuttle and the International Space Station, all of those use microwaves to talk to the Earth. Now, some of those satellites in space can be useful for broadcasting TV and signals all over the globe. You may in fact have one of these on the side of your house. I stole this from someone's house. This here is a microwave receiver. And what it does is it's a parabolic dish here that collects microwaves from satellites that are in geostationary orbits. They're fixed in the sky. And they bring those microwaves to a focus here on the microwave receiver. That then sends the information to your TV to be decoded and turned into lovely television. How nice. Lovely jubbly. Nice cup of tea, that. Microwaves are not just used in communications. Oh no. They're also used for heating food. You see, on the back, inside this here, a microwave generator is producing a very large amount of microwaves in here. And those microwaves bouncing around on the metal insides of this microwave oven are making the water molecules vibrate in anything that I put inside. The frequency of the microwaves on the back, which is written somewhere on here, 2,450 megahertz, is precisely the frequency that water needs to heat up. And so we can use microwaves in the kitchen for heating up all sorts of things. Now, microwaves are not dangerous, not in the kinds that are used in telecommunications. So, for example, your mobile phone is not dangerous. 4 and 5G mobile phone signals are not dangerous. They don't interact with matter other than create a very slight warming effect. There's only one frequency of microwaves that is of any danger at all, and it's the frequency used in this microwave oven. You see, if I was in there, I would heat up like my cup of tea, and that wouldn't be great. So long as my telecommunications avoid this frequency, the frequency that water absorbs, then everyone is fine and everyone is safe. But there is a point here, that telecommunication companies do not use this frequency for the simple reason that water does absorb it. It means that if you try to transmit at the frequency that water absorbs, then your signal wouldn't get anywhere because it would just have been absorbed by the water. Therefore, people that suggest that microwave radiation is dangerous, they don't know what they're talking about. Lovely jabbly. Time for a bit of Coronation Street. Now, this here is a remote control, an amazing device. Can you believe it, that before this was invented, you had to get up out of your seat and you had to go and turn on the TV and switch over the channels and buttons on the TV. What we used to do. And then someone invented this, and it was seriously good because it enabled us to be lazy, and that's what people will pay for, the right to be lazy. Now this uses part of the electromagnetic spectrum to send information to your TV, and it is not microwaves, nor is it radio waves, it is in fact infrared. Now our eyes cannot see infrared. You might have seen that there's a little LED at the top of your remote control. Now when you press the buttons you can't see it, but what I want you to go do is go find a remote control and look at it through the screen of your phone. You see, your phone is slightly sensitive to infrared, and if I start pressing buttons, what you should see is that the phone can see the signals that this remote control is sending. They're little flashes and little pulses, and the TV picks up those signals, understands what they mean, and changes the channel. So check this out. Underneath the floor of the science building, there are these giant red serpents. You can see that they are snaking all over the place. Look at that. Well, these are not really serpents, folks. What these are is underfloor heating elements. They're providing the heating that we enjoy here in the building. And you can see, they end here. No one down there is allowed any heat whatsoever. So what I've got here in front of the camera is a thermal imaging camera. It is something that can detect infrared and it can turn it into an image that we can see with our eyes. It enables us to see objects that are warm, and also it enables us to see things like reflected body heat. Here I can see my reflection in this glass window here. Now, this technology is used in things like night vision cameras, because though it might be dark, objects will still be visible, especially human beings, because of the heat that they're giving off. And so they're used all the time for military applications and in terms of crime fighting for seeing in the dark. You may have also seen these are thermometers that they stick in your ear in hospital to get an accurate reading. Sometimes they're pointed at your head as well. These work on looking at the amount of infrared that's coming from your body, and from that making a measurement of your temperature. With infrared radiation, infrared radiation is given off by hot objects. The inside of your oven is full of infrared radiation. So the dangers of infrared radiation are just like any environment that's too hot. So you could cook yourself. But generally speaking, the infrared radiation we use in telecommunications is of a wavelength and frequency that doesn't really heat us up as much as those wavelengths that do. So only some wavelengths of infrared are dangerous to us. Others we can quite safely use to turn on the TV or indeed see in the dark. Now let's talk about visible light. First of all, visible light can be used in telecommunications. It's not just a case of we can see, it's obvious that we can see. What is the technological use of light? And here I have some optic fibres. These we will talk about in more detail when we talk about total internal reflection. But what you need to know is that these can transmit light information from one end to the other. And in a combination of using visible light and infrared, this is how the internet works. So basically long optic fibres stretch underground and a flickering light signal is set off at one end. That is sent thousands of miles sometimes to the other end, where it is then received and decoded. Oh yes. Oh, work it. Oh yeah. Yeah, camera loves you. Yeah. Obviously, a use of visible light is photography. And photography is used in all walks of life. And it is better to say photography than saying seeing. The key thing, if you're asked to give an example of how visible light is used, don't say seeing, don't say using your eyes, because that's not a practical application, it's not a technology. Of course you see with visible light. It is the one part of the electromagnetic spectrum you can see. But better to refer to something like this, photography. Psst, let me tell you something. Visible light is not really dangerous. The only possible problem with visible light is if it is too bright. All of us have had that experience first thing in the morning where someone has very unsympathetically switched on a light. Ah! It's so bright out here. Okay. Light, if it is too bright, can damage our eyes. Now, our irises will contract to protect the photosensitive surface of our retinas, but just occasionally they don't react fast enough. So looking straight into bright sunlight, that's very bad. And of course, there are some things that are really quite dangerous, like you should never ever look at the sun through a telescope or binoculars, and also things like lasers. They are far too bright to be seen with the naked eye, so you have to be really, really careful with such things. But otherwise, light is wonderful, it's beautiful, look after your eyesight. That's the end.